the generic block diagram of an IoT system. Okay, so in your university examination, the question might be asked for explain in brief about the generic block diagram of an IoT system. What are the different kinds of qualities, interfaces are available, and how your device will be able to communicate the data while using different interfaces. So today we're going to discuss all these interfaces. Take an example of one of the IoT development board. Okay, take a simple example of Raspberry Pi. So what are the different kinds of interfaces are available on Raspberry Pi IoT development board? So in a general way, we'll be talking about a generic block diagram. Each and every IoT device should have at least these kinds of interfaces, connectivity interfaces. Let us talk about it one by one. Now, if I am talking about the very first one, that is related to the connectivity, it should have certain connectivity ports so that different devices can able to connect it physically, isn't it, with the help of cables or some guided medias. Take an example, very popularly we can have the USB port. Okay, USB 2.0 or USB 3.0, depends on the data rate wanted, you can use it. So on Raspberry Pi we have four, specifically talking about Raspberry Pi 3B plus. There are four USB 2.0 ports are available where we can connect four different peripheral devices to it. You can use your keyboard, you can use your mouse, you can use any kind of handheld devices directly with the help of this particular USB port. Okay, not only that, but also if I'm talking about the physical connectivity, I must say that this Ethernet port should be one of the important port for the communication. So whenever I'm talking about the Ethernet, indirectly I'm talking about the RJ45 jack or that port. RJ stands for your registered jack 45, isn't it? So traditionally we were having some small RJ11 jack we used in our telephone instrument to connect the cable. Okay, these jacks are used to terminate your cable so that you can easily plug into the any networking devices, isn't it? Here for our computers or laptops, we can having your RJ45 LAN port or NIC port, isn't it? Through which we can connect or plug any networking cable into it so that it will be getting the benefits of accessing the internet anytime, isn't it? So this Ethernet port should be available. So again, Ethernet, if I'm talking about the Ethernet, we're having the evolution of the Ethernet, isn't it? Ethernet will be considered as your standard Ethernet, the gigabit Ethernet, 10 gigabit Ethernet. I think you might be studying your ITCT or computer networks. Okay, the evolution. So 10 base T, 10 base F, 10 base TX, 10 base FX. Based on the different cabling used, take an example, I can use UTP twisted pair cable or shielded twisted pair cable or coaxial cable or optical fiber cables based on the bandwidth requirement, isn't it? So based on that, we can design our Ethernet contents, isn't it? So we can having the evolution in details. We are not going in a detail in that way. Only it's kind of introduction part. Okay. So each device should have an Ethernet port on which we can able to exchange the data. Now see, on any device here also on my laptop, we are having your Wi-Fi as well as your Ethernet port. So it should be having a data rate up to 1 Gbps or 10 Gbps. What are the latest laptops are available with us? Okay, so means your device will be capable of exchanging the data up to 10 or 1 Gbps or 10 Gbps. So it is a local data I'm talking about. Means if two computers are connected, if two devices are connected, they can mutually send and receive the data up to that particular data rate or speed. It is not a speed of internet. It can handle that amount of speed, isn't it? But that is not your internet speed. It is a intranet speed. That is a local network speed of your device. Once the connectivity issue means connectivity interface will be there. It's a physical connectivity I'm talking about. In the same way, we can have certain wireless kinds of communications, isn't it? So in that case, we can use your Bluetooth technology, we can use a Wi-Fi technology, we can use a Zigbee protocol. There are varieties of wired as well as wireless protocols are available. So each device should have a compatibility to send and receive the data wirelessly as well. Here it is not shown, but it should have that wireless connectivity as well, isn't it? Now, the second most important part, I'm talking about the memory interfaces. Each device should have the memory interfaces so that whatever the sensor data that has been captured that needs to be processed onto the development board, and to process the data real timely, we want certain random access memories, RAM. Okay, the DDR1, DDR2, DDR3 depends on the data rate or bandwidth, or talking about the speed of processing. Okay, DDR stands for your double data rate. Whatever the RAMs we are using in your laptop, okay, that is used for real-time processing of your data. And once the real-time processing, these are the volatile kind of memories, isn't it? If there is power, then and then only it will work. If power went off, then it will erase everything from your memories, real-time memory. So after that, once the real-time data has been processed, we need to store it locally. Okay, so for what purpose? So later on we can access that data and do our analytics, isn't it? So in that case, we needed another ROM kind of interface, memory interface, that can be developed with the help of certain logics, digital logics, the NAND, NOR logics, and we can develop our own memory interfaces. That will be considered as your secondary memory. DDR1's RAMs will be considered as primary memory. These are the volatile kind of memory, while the ROM memory will be considered as a non-volatile kind of memory, isn't it? Along with that, every device should have some processing capability. It should process the amount of data. So it might be having single core processor, double core, or quad core, or octa core. It depends on the application and the amount of data that has been captured by the number of sensors interface to it. Okay, but it should have a processing capability. Not only that, but also each IoT device should have the graphical processing capability also. What are the graphics, the graphical data that has been captured? Take an example of the cameras, isn't it? Camera is a kind of a sensory vision. Once it is interfaced with, suppose, a Raspberry Pi, so that particular huge amount of data that is being captured, so your processor should be capable of processing the graphics also, isn't it? Just like our laptop will be having your graphical processors, okay, for displaying purpose. In the same way, you need to represent it, whatever the data or video that is being captured. So that purpose, we needed the graphical processing in it. Along with that, every device should have the audio video interfaces, so that once the data, graphical data that has been processed, you need to represent it onto certain display devices. So this can be visualized with the help of your HDMI port, that is high definition multimedia interface. Okay, means these are the what you can say, we cannot use here compressed kind of data. What are the uncompressed data? Because HDMI capabilities is more, it will be capable of sending and receiving the data in Mbps or Gbps. So it can directly represent your uncompressed data onto your digital display devices. Okay, so high definition, whatever the pictures are there, videos are there, they'll be effectively represented on your display panels. Traditionally, we will be using, suppose currently also we are using this particular 3.5 mm audio jack, isn't it? So what this indicates, 3.5 mm. There are, if you are observing your connector, 3.5 mm connector will be having different set of readings, 1, 2, 3, 4. Okay, that will be indicated. Yes, what is 3.5 mm? And what are these rings specifically if I am connecting, suppose, onto my 3.5 mm jack of or mobile phone, isn't it? So there are different rings are there separated by, you can have the non-conducting kind of material. Anybody knows it? The one can be for your the microphone separately, one can be for your left and right side kind of audios, as well as some ground connectivity will be there. Okay, based on that, we are having varieties of rings available on that particular connector, jack connector, isn't it? So the audio will be reproduced effectively, as well as it can be received from the microphone with the help of this 3.5 mm jack. So it is we can get the data output from this particular interfaces. We can having another kind of connector. Every traditional television now, also in smart television, we can have this support of RCA video, isn't it? So it's a kind of connector through which we can have three different kinds of ports: yellow, red, and white. Yesterday I told you that yellow will be responsible for sending and receiving the video signals, composite video signals. The red and white is for your left and right hand side of audio onto your television that will be reproduced effectively. So for this we can use this, isn't it? Now we can have your these particular ports in your CD player also. Okay, in the same way, to connect the data cables from your CD player to your display devices. It will carry all the three simultaneous signals. Along with that, every device should have a kind of a storage interface, isn't it? So normally in our mobile phones also, we will be having external kind of storage as well as internal kind of storages as well. If I'm talking about external kind of storage, so this memory interface will be related to the internal kind of communication or internal memory suitable provided. This storage interfaces will be considered as a secondary kind of devices. We can plug it at any time. All these are the portable kinds of interfaces or the devices, small chips. Okay, so if I'm talking about the first interface, secured digital cards, isn't it? Means we can able to save our data in different data rates. So SD will be having varieties of types. If you go to the market and do the literature survey, okay, SD will be commonly represented based on the sizes or the capacity of that particular storage device. Okay, it will be divided into secure digital, then SDHC, that is high, then HDXC, extremely high, and SDUC. You see, so that is based on the your capacity of your devices. So SD will be having a capacity of up to 2 GB. Okay, the memory interface, the memory size for SD cards are up to 2 GB. For HDHC, that is high. Okay, so in that case, the data, the capability or storage capability is up to 32 GB. Okay, 32 GB. For HDXC, SDXC it is up to 2 TB, and finally for SDUC, okay, it is up to 128 TB. Okay, so based on your divided into 4 different types: SD card, SDHC card, SDXC card, and SDUC card, isn't it? In the same way, we can have another very popular kind of storage interface, the MMC, that is multimedia cards. I think you might be observed these kinds of portable cards that is widely used in your digital cameras. Okay, not only that, but also on your laptops will be having that particular slot. That slot will be considered as here SDIO, secure digital input output. So that is a kind of a slot available to plug your MMC or SD card, isn't it? So the main importance between the difference between SD card and MMC card. Anybody knows it? What is the main difference between SD card and MMC card? Or can I say both are same? Yes, you can comment it. If you're having, if you know the answer, you can write it in your chat box. Can I say SD card is the same as that of your MMC card? Yes. No. So now I'm explaining it. SD card and what is the main difference between MMC card? both will be considered as a flash kind of memory. Okay, both are we can say it's a non-volatile kind of memories, isn't it? Means if power went off, the data will not be erased. Okay, it will be considered as a secondary or ROM kind of memory. Okay, but it can be used, both SD and MMC can be used in different portable devices, but they will only differ by their physical sizes, capacity and usage. That's the only difference, or otherwise both are same. Okay, they will be only differ in the size. The SD card, MMC size having a different sizes, their capacities and usage always, where we can use it. Nowadays we are specifically using SD cards very widely, isn't it? So in the same way, traditionally we will be using MMC cards also. Okay, but only it will be differ with the physical constraints only. That's it, the sizes. Now the last and very important kind of interface every device should have, the IO interfaces, where varieties of input and output devices can have the connection with the IoT development board. So that will be via these IO interfaces. And now see, you can say that multiple sensors and actuators can be connected or can be able to exchange the data to this IoT development board by using all these four different the protocols, isn't it? These protocols are very widely and commonly used, and you might be aware about all the names of the IO interface protocols. So first one is the UART protocol, second is SPI protocol, third one I2C protocol, and fourth one is CAN protocol. Now I think you might be aware about it because you were aware about the coding or connection of any IoT devices. Take an example of Arduino Uno, isn't it? So Arduino Uno, if I want to upload the data or the program onto it, isn't it? We need to connect the USB cable. Okay, so that all these are, we can say it's a serial kind of a protocol, serial communication protocol, isn't it? So how they differ? What is the difference between UART? So UART stands for your universal synchronous transmitter receiver. SPI stands for your serial peripheral interface. Okay, and I2C will be considered as an integrated circuits. All these are serial kind of protocols, serial communication protocol. But how they are differing? The simple. Yes, anybody knows it? Have you ever used these? I think UART you can use it. SPI also used in controller to connect the controller to your devices or uploaders. But how they differ in? What is the main difference? Differentiation points between all these, what you can say, the serial communication protocol. Again, so pin indicates what? Means how many devices can be connected. Okay, we can say that maximum possible devices in a bus, because we can say it's a kind of serial communication buses. Okay, UART, SPI, I2C, CAN, these are the kind of buses used for exchanging the data from one device to or one controller to the other controller, isn't it? Now we can say that if I'm talking about first one, use a UART one. Okay, it's a universal synchronous asynchronous transmitter receiver. So it will be having a maximum speed of 150 kbps only. 115 kbps. So the devices can be able to exchange the data using this small amount of speed up to 115 kbps, and the devices should be having a maximum distance between them is up to 15 meters. So the distance plays a very vital role. Connection, speed, and the distance. How far the distance means devices are able to exchange the data, isn't it? So with the help of UART, the distance between the two devices should be approximately equal to maximum 15 meters. If it is more than that, the UART communication will not be possible, isn't it? And we can connect minimum, or sorry, the maximum 2 devices only in UART, isn't it? Only 2 devices can able to share this particular bus. Okay, that is about the UART communication. Now next one, we can say that SPI, the serial peripheral interfaces. So minimum, we can say virtually unlimited number of devices can be connected with the help of this particular buses, SPI bus, isn't it? So the SPIs differ with UART is for the speed and the distance. So the maximum speed of the SPI is up to 4 Mbps, okay, which is very much greater than UART. The data can be exchanged or uploaded at a very faster rate. For UART, it is only 150 kbps. For SPI, it is up to 4 Mbps. But the distance between the two devices are very much least in SPI. It is only 0.1 meter. Okay, in UART, it is 15 meters. But in SPI, only 0.1 meters. So devices should be as closer as possible. But they will be exchanging at a very higher rate. If I am talking about I2C, okay, inter-integrated circuits. Now here we can say total 127 devices can communicating with each other simultaneously with the this particular serial protocol, okay, where the maximum speed will be 1 Mbps, but the distance between the devices should be 0.5 meters. Okay, now here the data rate is okay, is up to 1 Mbps, and the distance is somewhat greater than SPI, that is up to 0.5, but it is always lesser than UART. Okay, and we can connect 127 devices in that particular buses. And finally, if I am talking about now, before the CAN, we are having another kind of connector, RS485, RS485. So that will be having a same data rate as just like UART, but the maximum distance between the devices are up to 1.2 kilometers, isn't it? So very far. Okay, so in networking, we want to send some serial data from one device to the another one. Okay, specifically in telecom industry. In that case, we can use this particular interfaces, RS485. And CAN protocol is very widely used. So Robert Bosch, who have invented this particular protocol, and it is very much widely used. Initially, it was used in automotive sector only. Okay, in your vehicle, multiple ECUs are there, and they will be able to exchange the data with the help of this particular controller area network. Okay, that CAN bus, isn't it? CAN high, CAN low. Okay, and up to certain kbps of data, or up to a certain Mbps of data. But because of the popularity, nowadays we can use the CAN in different appliances, in different smart televisions, in different kinds of IoT devices, where devices are able to communicate with each other with the help of this particular very popular CAN protocol, isn't it? So this is what you can say, the generic block diagram. Every IoT device should have these capabilities. Okay, so in examination, the question might be asked for 8 marks. Protocols. If I am talking about, in previous lecture, we have discussed certain about the protocols, that is TCP/IP protocol layers and IoT layers. We'll be talking again the same way. Okay, so here we are having here 4 different layers. In TCP/IP, again we are having a 4 layers. The bottommost layer will be considered as host to network. Is a combination of physical layer and data link layer. In IoT, it will be considered as a link layer. Okay, it will be considered as a link layer. And if I am talking about the link layer, it will be having wireless capability as well as wired capability. So 802.3 is the Ethernet port, LAN port. So we can connect 16, that is the YMax. Okay, or we can have 802.11 as a Wi-Fi. We can have 802.15.4, that is low rate wireless personal area network, or we can go for the 2G, 3G and LTE or 4G, 5G kind of communication. Now we'll talk about one by one. Okay, so I think you might be aware about the Ethernet evolution. We have discussed it. Okay, standard Ethernet, fast Ethernet, gigabit Ethernet and 10 gigabit Ethernet. It depends on the data rate provided. So take an example of 10 base T, okay, or 10 base 2, okay, 10 base 5. So what it indicates, 10 indicates is the data rate, okay, the speed. 10 Mbps will be the capability of exchanging the data. Base indicates the baseband signal. We are exchanging the data or signal, that is a baseband signal. And if I'm talking about 5, okay, or 2. Okay, 5 indicates the distance between the devices. I'm saying it's a 500 meters. Okay, 2, if I'm saying it's 2, it is 185 meters approximately. Okay, so in this way the devices can use a thick coaxial cable or thin coaxial cable to connect different devices physically or with the help of certain guided LAN cables. So that is regarding 2.3. If I'm talking about IEEE 802.11, okay, so this is nothing but your Wi-Fi. So it's the Wi-Fi fidelity. Okay, Wi-Fi stands for Wi-Fi fidelity, where it will be working on 2 frequency bands. If you observe, if you want to purchase a Wi-Fi router, if you go to the market, you will be getting various routers. uh, Suppose the Cisco router or D-Link router. Okay, varieties of manufacturers are there. Okay, certain devices will be having single aerial, dual aerial, or 4 quad aerials are there. Varieties of different antennas will be there. So they will be working using different frequency bands. So if I'm saying it's a dual band frequency or single band frequency, so single band means it will be using 2.4 gigahertz of frequency, 2.4 gigahertz of frequency. And if I'm saying it's a dual band, so it can use 2.4 gigahertz as well as 5 gigahertz. If a device is capable of having the dual band kind of connectivity, so its data rate is very much higher. So for 2.4, you can able to exchange the data up to 20 Mbps speed. But if I'm using a 5 gigahertz of frequency range, it can be able to use up to 40 Mbps of speed. Okay, you can check in your Wi-Fi router also by selecting an appropriate channel into it. Got it? Now, this will be considered as Wi-Fi. You can provide certain encryption algorithms. Okay, the encryption algorithms we can say is a WAP. You can simply go to the firmware of your router. It will be showing WAP, then WPA, WPA PSK2, PSK1. Okay, means these are the encryption algorithm. Okay, so we can use Wi-Fi protected access. WPA stands for the Wi-Fi protected access. Okay, so means you can choose any one of the algorithm to secure, to encrypt your data that can be exchanged via your Wi-Fi router. Means your wireless personal area network should be secured one. Okay, so in that case we'll be using these different authentication or encryption algorithms. Got it? Now, if I'm talking somewhat more regarding the next IEEE standard, so it is 802.16. So this is a YMax. So YMax stands for, it's a wireless interoperability for microwave access, isn't it? So if I want to connect, take an example, what is the drawback of Wi-Fi? The Wi-Fi is having certain range up to certain meters. Suppose it will be having up to 250 meters to 300 meters. Any device within the particular range will be capable of receiving the coverage or wirelessly data. Okay, so up to 300 meters. What happens if the devices are very far to each other? Now take an example, in the region in a specific city. Suppose in Pune, I have one device at Hadapsar, another device in Shivaji Nagar. Okay, so means these are the very far devices. The distance between the devices are very far. In that case, I'll be going with the YMax. The data rate achieved is up to certain kbps only. The data rate achieved by the Wi-Fi Max, the YMax is from kbps to certain mbps to certain gbps. So depends on the applications required, isn't it? But they'll be carrying more signal. Okay, up to certain extent. So it can cover a MAN network, that is metropolitan area network, where the devices are located at a very far distance, isn't it? Now if I'm talking about the next one, 802.15.4, that is very popularly used in IoT. This particular standard is very popularly used because it will be using LR, that is low rate. LR stands for very low rate, up to certain, suppose 125 kbps of data, of just like I think your IR is capable of exchanging the data. Okay, so its capability is only 125 kbps. Okay, but it will be using a wireless personal area network. Okay, so here it will be using this low rate data technology to send the data over certain range of the devices. Not, it is not more than the YMax, but it is more than the Wi-Fi. Take an example of your Zigbee protocol. Zigbee protocol. Okay, so Zigbee protocol, obviously it will be having a maximum range than the Wi-Fi, but the limitation of the Zigbee is having the data rate. Okay, for Wi-Fi it is up to certain Mbps, but for it is Zigbee, it is only for certain kbps of data, and it is also power consumed. The power consumed by the Zigbee is very much lesser. A single battery can long last up to 10 years. You cannot believe it, up to 10 years. But in Wi-Fi, it will be using a huge amount of power, isn't it? So that is why the Zigbee, specifically I'm talking about 802.15.4, so very widely used kind of technology in IoT domain, because it will be using very small amount of power, but it will be radiating the data with the small frequencies. So we'll be using a small data rates. Okay, and now see, every device should have this particular communication. Nowadays we are using on our mobile phones, that is the 2G, 3G, 4G. Now this is, if you are talking about the evolution of this particular mobile cellular technology. Okay, so whenever we can talk about the 1G, it was developed in 1970s. Okay, and it will be using the frequency of 30 kilohertz only, 30 kilohertz, and able to get the bandwidth of up to 2 kbps. You cannot imagine it, up to 2 kbps. Okay, and they were using the access system as an FDMA, and it can be used to connect the devices in the form of PSTN network. I don't know how many of you have heard about it, PSTN, public switch telephone network. When I was working in an industry in 2006, okay, so we were using this particular technology, PSTN. Okay, being a network engineer, what we always do, we need to connect the devices. Okay, with the help of certain modems. Okay, so we always create our dial-up modem. We need to do certain dial-up modems, and initially we need to call it. Okay, once the session is developed, then and then only we can connect or exchange the data up to certain kbps. It was very much slower. It will take a huge amount of time to send and receive the data or email or any kind of application data. Okay, so we were using this particular PSTN. So we were using 2G kind of network. So the next evolution is the 2G. We used in up to 1980 to 1999 up to. Okay, it uses 1.8 gigahertz of frequency, and get the data rate up to 64 mbps. Now if you are observing it, the modems, okay, the modem stands for modulation demodulation. Okay, what the modulator does, it will convert your digital signal into analog signal, and that can be broadcasted. At the receiver side, your analog signal gets converted into digital signal with the help of demodulator, isn't it? So in that case, what happened, the modulator or modems can be again used to develop the dial-up kind of connection. So it will be capable of getting the data rate of 64 kbps of data, 64 kbps. Okay, and again they will be using a CDMA kind of technology or TDMA kind of technology. But if now we are approaching towards 3G, okay, now that particular standard was developed in 1990 up to 2002, that was worked. Okay, it uses the technology as WCDMA, and the frequency is up to 2 gigahertz. Okay, from 1.6 to 2 gigahertz, and the data rate HUD is now, it is very much drastically increased to 2 mbps. Earlier it was only 64 kbps. Now it was increased to up to 2 mbps, and it can be possible because of the CDMA technology, and they uses the packet networking. Okay, packet networking. If you are aware about the switching technology in PSTN, in normal telephones we use the switching networking. Okay, switching technology. Okay, but in packet network, what happened, packets are broadcasting, no need to establish the session or releasing the connections. Okay, so here using the packet network, just like in internet we are using it, whatever the data we are having, simply broadcast it. Okay, no need to establish the session, releasing the session. In 4G, what happened? We use the technology in LTE or YMax. Okay, and the amount of frequency the used is 2.8 gigahertz, and you are getting the data rate up to 1 Gbps now, the very higher. The drastical change from 3G to 4G. Okay, because we are dealing with LTE kind of communication, isn't it? So it will be getting a data rate of 1 Gbps, very widely used. It using the same CDMA kind of technique, and the amount of the network, the kind of network we are using here, the internet. Okay, widely used. And in 5G technique, we are using MIMO kind of communication. The aerials we are using multi-input, multi-output, and the frequency using is up to 30 gigahertz. And the data rates we can achieve, it will be more than 1 Gbps. Okay, and here we can use the technologies, access technologies, OFDM, orthogonal frequency division multiplexing, through which we are getting maximum amount of data. Okay, so these are some of the details about the brief introduction about the link layer contents. Okay, next layer will be considered the network layer, where I'm talking about the devices can be connected globally via this network layer. So network layer is responsible for exchanging the data from source to directly the destination. Okay, with the help of your addressing schemes such as IP version 4, IP version 6, or 6LoWPAN. Okay, this 6LoWPAN is newer to you because it uses IP version 6, but uses a low power. Okay, it uses a low power we can create the network. Okay, that is a wireless personal area network. Okay, and if I'm talking about the transport layer, these are the two widely used transport layer protocols. In TCP/IP also we are using the same kind of protocol. TCP stands for Transmission Control Protocol. UDP stands for User Datagram Protocol. These protocols are very widely used in different applications. Okay, as I said, TCP is a connection-oriented protocol. UDP is a connection-less protocol. So connectionless, can I say connectionless is a wireless? No. Connectionless means what? And what is meant by connection-oriented? First, the connection needs to be established. Once the connection is established, then the data can be transmitted. And once the data is successfully received, then the establishment of link was there, that can be released. Isn't it? So three phases are there: setup phase, data transfer phase, and tear down phase. Okay, tear down will be considered as an releasing of your connections. But in UDP, there is no as such kind of phases are there. Simply the data is broadcasted. It's a connectionless. It cannot generate, establish the session, as well as it cannot terminate the session. Directly the data will be broadcasted. So that is why UDP is more faster than the TCP. We didn't bother about the acknowledgements. In UDP, you never get the acknowledgement. But in TCP, it's a reliable kind of communication protocol. We want the acknowledgement. In certain applications, we want the acknowledgement for the security purpose. In that case, we use the TCP. And that is why we widely use the TCP protocol in internet. That is a TCP/IP model. Okay, to make the IP protocol more reliable, we can attach this TCP to the IP. Okay, so in real-time communication, we can use the UDP. So to send and receive the signal on WIP, that is Voice over Internet Protocol, is the very fastest protocol. Or we can have SCTP, is a combination of TCP and UDP, or certain RTPs, real-time transmission protocols. We can use it. Okay, these are something basic about the transport layer. And finally, the application layer. So varieties of applications are there. Very popularly used HTTP, that is Hypertext Transfer Protocol. Normally we use this for browsing the data. Okay, so if you want to browse any specific websites, we can use the HTTP or the secured version of HTTP as the HTTPS. Okay, so it's a client server kind of communication. Client will send the request to the server, and server will respond to that particular request by providing the services or the web page to you. Okay, so it is a client to server communication, and the HTTP can use varieties of different commands, just like we can have the get command, put command, post command, delete command to interact with the client as well as server. Okay, is a very widely used. The same we are going to discuss here some different application protocols in IoT. Okay, Take an example of first is a COAP protocol. It's a constraint application layer protocol. The constraint, now name itself indicates its meaning. Constrained means this particular protocol can work in a constrained environment for the constrained devices, for the constrained network. Now we are having varieties of problem. Your network is very much noisy, environment is very much noisy, your device is not up to that particular mark. Still, this particular lightweight protocol will work and able to exchange the data effectively. So in constrained applications, we can go for using the COAP protocol. This WebSocket is able to is responsible for sharing the data. Okay, it allows a full duplex communication over a single socket kind of connection. Okay, so whenever you're talking about this WebSocket protocol, it will be related to your data exchange. It will be using a full duplex kind of communication over a single kind of socket programs. Okay, MQTT is related to the message queuing telemetry transport. Okay, this particular protocol is very widely used in varieties of IoT applications. So it's a publish subscriber kind of communication. PubSub, commonly known as PubSub kind of communication. Are you aware about publish subscriber kind of communication? Just like client to server communication, we have the PubSub kind of communication, publish and subscriber. Take an example. We are having a temperature sensor, and that will be considered as a publisher. Okay, it always publish the temperature values, isn't it? Now this will be considered as a publisher. So we are having intermediator called as a broker. Okay, we are having a broker as an intermediator. So publisher sends the data to the broker, and broker have certain set of topics. These are the list. Suppose I have input various sensors, temperature, humidity sensor, then light intensity sensor. So each and every sensor will send their data to the broker. Broker will be having different topics. Okay, temperature topic, humidity topic, and light intensity topic, and each user can subscribe to each and every topic, depends on their area of interest. Suppose I am interested in knowing the current humidity or in a Pune, so I am interested only the humidity topic, so I can subscribe to that particular channel or topic. So this broker is responsible for sending getting the data from the sensors, and it will be sending to the users directly. Those who are subscribed to that particular topic, the data will be sent to that particular user, isn't it? So this is a kind of public subscriber kind of communication. We'll be talking in details in your third unit, where we are going to discuss these protocols very detailedly. Okay, so this MQTT protocol is a stream oriented protocol. A stream will be generated. Okay, it's a very lightweight protocol, and that's why it is widely used in IoT applications. Got it? Now we have the XMPP protocol. The XMPP is an extensible markup messaging and presence protocol. Sorry, XMPP stands for Extensible Messaging and Presence Protocol. This protocol is widely used for real-time applications. In your WhatsApp, or Skype, or in Facebook, or any real-time video as well as audio conferencing tools or chatting tools, we are using this XMPP protocol. It will be capable of not only sending the messaging, but also for finding the presence of a user, whether the user is currently alive or not. Within means it is currently logged in or not. Okay, or we can widely use this protocol for real-time playing of games. Okay, remote location games. If I want to play the games online with my friend, so I can use this particular kind of protocol. Okay, it's a very fastest and lightweight protocol. Or for multi-chat party chat or voice or in form of videos, I can use this particular XMPP protocol. So how it works actually, I think you might be aware about XML kind of language, that is extensible markup language. So this XMPP protocol can be capable of exchanging the data chunks, XML data chunks I am talking about, for it will be kind of a client to server kind of communication, to able to exchange it from source to the destination. Okay, certain data XML chunks can be transmitted and effectively utilized for sending the data for different applications. Now, next is the data distribution system. Okay, if you want to distribute your data, we need to unicast it, multicast it, or broadcast it. Depends on this particular protocol. We can use that particular application. And final one, we can have AMQP. That is your. We can have the asynchronous messaging and queuing protocol. Okay, so in that protocol, again, it is kind of a pub sub kind of protocol, publish subscriber, but it is, we can say that it is a buffer oriented protocol, buffer memory, isn't it? We are having certain messaging queues. So just like a topic in MQTT, in AMQP, we have different messaging queues. These are the buffer memory queues are there. So the data by the broker can be taken from the sensors, isn't it? And it will be sent to the different queues. We'll be having different high as well as low priority queues are there. So depends on your subscribers, okay, or the users. They can pick up, fetch the data from respective queues one by one, depends on their request. Okay, applications are somewhat same, but we can use it in different real-time kinds of communication. Okay, so we'll be going to discuss these protocol in details. Only it is a brief introduction of it, so that's why I'm showing it very briefly. In third unit, we're going to discuss it very detailedly, how it can able to exchange the data, isn't it? What are their applications? Okay, how you can design it, how you can use it in a cloud. So this again, this particular question asks for 8 marks.